Hello, I'm the awesome Tutor, and today we're going to be looking at coordinate geometry in C2. So, finding the midpoint of a line. Okay, you're basically finding the mean average of the x coordinates and the mean average of the y coordinates. So, imagine this is our line. Find the two endpoints and their coordinates, so x1, y1 and x2, y2. Then you find the mean average of the x values and the mean average of the y values. So x1 plus x2 over 2, that will give you the x coordinate of the midpoint. y1 plus y2 over 2, that will give you the y coordinate of the midpoint. Okay, find the midpoint of this line. Go, pause the video. Okay, so again, x1 plus x2 over 2, so 2 plus 4 over 2, that's going to give you 3. And 5 plus 3 over 2, that's going to give you 4. So your midpoint is 3, 4. But then again, did you really need this equation? Did you really need to write it all out? 2 plus 4 over 2 and 5 plus 3 over 2? I mean, clearly, the midpoint between 2 and 4 is 3, and the midpoint between 5 and 3 is 4. So sometimes you don't even need to write it all out, you just know in your head. It's common sense, it's not that hard. You don't even need this formula. So, the distance between 2 points. This looks really complicated. Not really, it's just Pythagoras. Okay, here's your line, the two endpoints and their coordinates. Okay, so the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So again, I said is basically Pythagoras. Find the distance between these 2 points. Go. Okay, so again, Pythagoras, so draw out your triangle. The difference in x is 5, and the difference in y is 4. So x2 minus x1, that's minus 5, but keep it a positive. Doesn't really matter. If you're squaring a negative, so minus 5 all squared, that's going to give you 25. If you're squaring positive 5, it's also going to give you 25. So it doesn't matter if it's negative or positive, but I like to keep it positive. Okay, the y difference is 4, so you find the length of the hypotenuse, Pythagoras. Alright, the answer is root 41, or 6.40 to 3 significant figures. If you see the words exact value anywhere on your exam paper, keep it as a surd, okay? Not as a decimal. Okay, now onto circles. So the equation of a circle is given by x minus a all squared plus y minus b all squared is equal to r squared, where a, b are the coordinates of the center of the circle, and r is the radius. Okay, now onto some key theorems and rules which you need to know for this chapter. The perpendicular from the center of a circle to a chord bisects the chord. Now, what the hell does that mean? Okay, here is a chord, okay, a line connecting 2 points on a circle. Here is the center of the circle. If you draw the perpendicular of the chord to the center, or the perpendicular from the center to the chord, okay, it's going to bisect the chord, meaning that it is going to split the chord in half. So this length will be the same as this length. The angle in a semicircle is a right angle, always. 2 lines from the endpoints of the diameter, okay, that has to be the diameter because we're looking at a semicircle, alright? And these 2 lines from the endpoints of the diameter connecting to any third point on the semicircle is always going to give you a right angle, no matter where the third point is. Alright, if it's there, still a right angle. If it's there, still a right angle. Even at the bottom of the circle, if we're taking the bottom half of the semicircle, it's still going to be a right angle. Alright? So any angle in the semicircle is always a right angle, as long as these 2 lines are chords. The angle between a tangent and a radius is 90 degrees. Alright, the radius from the center of the circle to the point where the tangent touches the circle is always going to be the perpendicular of the tangent, so 90 degrees. Now, I don't know how to put this into words, but it takes into account the perpendicular bisector rule we were talking about. So if we have, say, 3 chords, we find the midpoint of each of these chords, and if we draw a perpendicular line to these chords on the midpoint, it is always going to go through the center. Alright? Doesn't matter which chords you choose, the minimum you need is 2. So if you chose this one and this one, doesn't matter because it will still go through the center. To find the coordinates of the center, you need at least 2 chords. I need to find the perpendicular bisector of these 2 chords, and where the lines intersect is where the center of the circle is. That is very useful in exam questions. Alright, why don't you try a question? The points A, -4, 0, and B, 4, 8, and C, 6, 0, lie on a circle. The lines A, B, and B, C are chords of the circle. Find the coordinates of the center of the circle. Pause the video, have a go. Okay, the first thing I would do is sketch the circle. Always, alright? Roughly where the points are, and draw the 2 chords that it gives you. Alright. Now to find the coordinates of the center of the circle, you need to find the perpendicular bisector of these 2 chords. Alright, and where those 2 perpendicular lines meet is where the center of the circle is going to be. The only thing is, I personally would not use the 2 chords A, B, B, C. I would at least use the chord AC. Why? It's a straight line, so finding the equation of the perpendicular line is much easier. Is it not? So, if we start with AC, the midpoint is going to be 1, 0, alright? So find the midpoint, and then the equation of the perpendicular bisector. You need the equation because in order to find where the 2 perpendicular lines meet, you need to put them equal to each other, so simultaneous equations. So therefore, you need the equation of the perpendicular bisectors. Now we have the perpendicular bisector for AC. We just need one more. So whether you choose AB or BC, doesn't matter, but in this case, I'm going to choose BC. So the midpoint of BC is 5, 4. Okay, so remember y1 plus y2 over 2 and x1 plus x2 over 2, blah, 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 blah. You're just finding the mean average of the x coordinates and the y coordinates. The gradient of BC, alright, rise over 1, minus 8 over 2, -4. To find the gradient of the perpendicular, it is going to be 1/4, alright? Times by -1, do the reciprocal. You should already know this from C1. And then you use this formula to find the equation of that line, right? Y minus y1 over x minus x1 is equal to the gradient. Remember, you're using the midpoint because you have to find the perpendicular bisector, alright? So at the midpoint. So use the y value of 4 and the x value of 5, alright? And then you rearrange, and that is your equation of the perpendicular bisector at BC. Now all you have to do is find where these 2 lines intersect, where they meet, and that is going to be where the center of the circle is. So you do simultaneous equations. Alright, substitute the value of x is equal to 1 into the equation y is x over 4 plus 11 over 4. You get y is equal to 3. So, the coordinates of the center of the circle are 1, 3. X is 1 and y is 3. Easy. So, try this question now. Okay, so again, sketch the circle, roughly place your points, and draw out your triangle. Now, by sketching it, alright, it says show that the triangle RST has a right angle. By sketching it, you can roughly see where the right angle is going to be. I think it's going to be there. So to prove that it has a right angle, we need to prove that the lines RS and ST are perpendicular. Alright? So the gradient of RS is 1 over 11. Alright? Rise over 1. Gradient of ST is -11. To prove that they are perpendicular, we multiply the 2 gradients together, and if we get the value of -1, then the 2 lines are perpendicular. If they are perpendicular, then they must make a right angle. So therefore, the triangle RST has a right angle. Now for part B. Okay, find the equation of the circle. So we need to put it in the form x minus a all squared plus y minus b all squared is equal to r squared. So to find the equation of the circle, we need to find the coordinates of the center of the circle, a, b, and the radius r. Now, The long way round, and the way that always works, is going to be find the perpendicular bisector of two chords and find where the two lines intersect. But in this case, I'm not going to do that because there is a shortcut for this question. There's a reason in part A it asked you to show that RST has a right angle. Because by showing it has a right angle, you're showing that these three chords are part of a semicircle. And remember the rule I told you? An angle, any angle in a semicircle is going to be a right angle. So if there is a right angle here, then this is a semicircle, which means that RT must be the diameter. And if we know which line is the diameter, then finding the coordinates of the center is easy. We just find the midpoint. And finding the radius is easy. We just find the distance of the diameter and divide it by 2. Easy. We don't have to find the perpendicular bisector of two chords. That's going to take way too long. If we know there's a right angle, we know it's in a semicircle, then we know that therefore RT is the diameter. So from that, we just find the midpoint, which is 2, -2, and therefore the coordinates of the center are 2, -2. Alright, we know what A is, we know what B is. Now finding the radius. So Pythagoras, alright? The difference in y is 10, the difference in x is 12. The square root of 10 squared plus 12 squared, no matter if it's negative or positive, because it's going to give you a positive square number either way, okay, because all square numbers are positive. Alright, you get the value 2 root 61. Remember, to half it, because that is a diameter, not the radius. I have made this mistake so many times, alright? You have to half it to get the radius. The radius is root 61. So, r squared is 61. There we go. The equation of the circle is x minus 2 all squared. Alright, so x minus a, so x minus 2, plus y plus 2 all squared. Alright, because it's y minus b, so y minus minus 2. Alright, so it's y plus 2. Y plus 2 all squared is equal to 61, because that is r squared. Not root 61, 61, okay? Because it's r squared. That's it. This has been the Awesome Tutor. Bye.